Hello, this is page 2 of the notes on similar solids, and as a reminder, please write down any questions in this left-hand column that you may have that may arise at any point during the video. So let's take a look at example 2. Two similar cones have surface areas of 384 pi and 216 pi feet squared. Find the ratio of radii of the cones by finding the ratio of the surface areas. So you want to think about, where do we put surface areas? Is it going to go into A to B, A squared to B squared, or A cubed to B cubed? Sometimes the units themselves are actually really helpful to identify where things go. You see how there's a little 2 here? It's kind of a clue that we want to have the middle one, A squared to B squared. So I'm going to write down 384 pi to 216 pi. And I have a tendency of doing the first one over the second one. Doesn't matter to me which one's bigger or smaller, it's just first to second. Now, I always think it's helpful to simplify the fractions. So I'm going to cancel the pi's. And what I'm going to do is I'm going to use a very special feature on the graphing calculator. So I'm going to do 384 divided by 216. That is not the special feature. What I'm going to do is press Math, and the first option allows me to change my answer into a fraction. Press Enter again, and we get 16 over 9. So this right here is equivalent to 16 over 9. If you are lacking in a graphing calculator and you want to know how to do this, you just start simplifying the numbers. So you want to think about what goes into 384 and into 216. They're both even, so I'm going to divide it by 2. So I'd have 384 divided by 2 gives me 192. 216 divided by 2 gives me 108. They're still both even, so I'm going to keep on going. I'm going to divide by 2 again. So now I have a 96 over a 54. Still even, but you know what? I kind of noticed that I think 3 goes into both of them. So I'm going to divide 96 by 3, and I'm going to divide 54 by 3. So now I have a 32 over 18. And now if I divide top and bottom by 2, I'm going to get 16 over 9. So it takes a little bit longer if you don't have a graphing calculator, but you can still get to the same place. Now, hopefully you've already watched the first video and you remember how to go from this column to the first one. So I'm going to square root both the top and the bottom to get there. So the square root of 16 is 4, and the square root of 9 is 3. So my answer is actually going to be 4 to 3, because I want the ratio of radii, and this is a radii number. Okay, and you can write it as 4:3 as well. That would be acceptable. So let's take a look at example 3. Two cubes have volumes of 128 meters cubed and 2,000 meters cubed. Find the ratio of the sides of the cubes by finding the ratio of the volumes. So again, we want to think about, where do these numbers go? Is it an A to B, an A squared to B squared, or an A cubed to B cubed ratio? And again, I'm going to use my word clues and my little exponents to help us figure that out. Either one of those is a good clue to say that I'm going to put it into this category. So I'll have 128 over 2,000. Now again, I'm going to simplify this, and I'm going to take 128 divided by 2,000. I get this decimal number. Math. Oops, wrong math class. And now I have 8 over 125. If you had to do this by hand, hopefully you recognize that I think 8 goes into both top and bottom. I think it actually might be 16. Let's see. Yep, it's 16. Okay. So from here, we want to find the ratio of sides. Well, is that an A to B number or an A squared to B squared number? Nonetheless, I need to go here first, and to do this I'm going to use the cubed root feature. So we're going to type in option number 4. I want the cubed root. Cubed root of 8 is going to be 2. Now I want the cubed root of 125, which will be 5. and this will be my ratio of sides. Oops. Yes, there you go. You can see it. All right, example number 4. Two rectangular prisms are similar where the ratio of sides of A to B is, oh, that's not really well read. Two rectangular prisms are similar where the ratio of sides is A to B of 1 to 4. Huh. I have a feeling I meant this. Of A to B is 1 to 4. There we go. Find the surface area and volume of prism B given that the surface area of prism A is 28 square feet and the volume of prism A is 8 cubic feet. Okay, I'm going to actually chop this example in half because I think it'll be a little bit easier if we just focus on one thing. So I'm going to take out, find the surface area. Sorry, I'm going to take out and volume. So just find the surface area of prism B given that the surface area of prism A is 28 square feet and leave it at that. So that's going to be a simpler problem to look at. Now, looking at this, I'm going to start with this idea. So I'm actually going to write that down. I'm going to have my A to B number, my A squared to B squared number, and my A cubed to B cubed number. And the kind of clues I'm looking at are things like the word similar. When I see the word similar, I'm going to think something like this. The other piece is the word prisms. Because it's solids and it's similar, I really do want to use this. If it was just similar, maybe all I needed was a ratio. But if it's prisms, it could be areas, it could be volumes. So you really have to read the question carefully to think about what tools you're going to need. So looking at this, we have a ratio of sides is 1 to 4. So where am I going to put this 1 to 4? Hopefully you recognize it goes over here. Before I do anything, I'm going to find the other two. So if A to B is 1 to 4, A squared to B squared is going to be 1 to 16. If A to B is 1 to 4, then A cubed to B cubed is going to be 1 to 64. Now keep in mind, if you're stuck in where I'm getting these values, remember it's all about 1 squared, 4 squared. 1 cubed, 4 cubed. That's where I'm getting these numbers. Now, before I decide on what's happening next, I'm going to read the next sentence. Find the surface area of prism B given that the surface area of prism A is 28 square feet. Well, here's the thing though. I want to find surface area, so that's going to be going here. Now you see how it's A to B? I'm going to just make a little note. A to B, A to B. Just so I know that A is on top, B is on the bottom. It says find the surface area of prism B. That means that B is unknown, given that the surface area of prism A is 28. So you see how I have values in this column? This is what I'm going to do to solve for my missing surface area. So I'm going to have 1 to 16 is equal to 28 to x. Now I just cross multiply to solve. So x is going to equal 16 times 28. So x is going to be 448 square feet. All right, just to recap, just in case you needed to hear this again, I found all three ratios, and then I read the problem. I'm looking for a surface area of B. Well, B is on the bottom, so I put my x in the denominator, and its surface area, which is why I put it in this category here. They gave us the surface area of 28. Well, A is on top, that's why I went over here. And when it comes to similarity, you often use proportions to solve. So 1 over 16 is going to equal the ratio of 28 to x. We cross-multiplied and solved for our unknown. If you have any questions, good time to write down a question. Just pause the video if you need to. All right, let's take a look at the last example. Two similar punch bowls have a ratio of radii of 4 to 5. The amount of concentrate to be added is proportional to the volume. How much concentrate does a smaller bowl require if the larger bowl requires 32 ounces? So looking at this, I see the word similar, and I see the words bowls. So bowls are solids, so I'm going to write down A to B, A squared to B squared, A cubed to B cubed. Now the ratio of radii is 4 to 5, so 4 to 5 comes over here. Doesn't matter if you write it with the colon or if you write it as a fraction. I just like fractions better. Now, before I do anything else, I'm going to fill in these two spots. So this will be 16 to 25. A cubed to B cubed is going to be 64 to 125. So again, this is 4 squared to 5 squared. This is 4 cubed to 5 cubed. So now looking at this, I'm going to read the second sentence again. The amount of concentrate to be added is proportional to the volume. So how much concentrate does the smaller bowl require if the larger bowl requires 32 ounces? Well, the smaller bowl requires some unknown amount. That goes on top because the smaller number's on top. The larger bowl requires 32 ounces, so that's going to go on the bottom. And again, it's all about the volume because it's proportional to the volume. So this is what I'm going to use to solve for x. So I have 64 over 125, and that equals x over 32. So I'm now going to cross multiply to solve for x. So I have 125x is equal to 64 times 32. So 125x is equal to 2048. To solve this, I'm going to divide both sides by 125. $16.384. Now, because the decimal terminates, it doesn't keep on going, I feel no need to round. I'm just going to leave it as the 3 decimal places, and that's going to be the answer, so 16.384 ounces. To recap, we used the ratio, filled it into the A to B column. We found both the A squared to B squared ratio and the A cubed to B cubed ratio. We looked at the second sentence. Since it's proportional to the volume, I put this information here into the volume category. The larger bowl requires 32, which is why I put on the bottom. That matches what I have up here, the larger numbers on the bottom. So my smaller number, my smaller bowl, goes on top, the x. So I wrote my proportion, cross-multiplied, and solved for x. At this time, please write down any questions that you may have, complete your summary, and please complete the how did I do problems on the following page. Please give it your best effort to write something down and solve these problems.